Students, in this video, we are going to learn the importance of studying the degrees of freedom for t-statistics with the difference between two dependent or correlated means. Degrees of freedom. In many scientific fields, the degrees of freedom is the number of parameters involved in the system that may vary independently. The degrees of freedom in statistics indicates the number of independent values that can vary in a statistical analysis without breaking any constraints. Degrees of freedom is the number of independent values that a statistical analysis can be obtained. Degrees of freedom is a term used in explaining dependency on parameters or the dimensions of a phase. One can also think of it as the number of values that are free to vary as estimate parameters. Degrees of freedom is the number of values in the final calculation of a statistic that are free to vary. The degrees of freedom equals to the sample size minus the number of parameters you need to calculate during an analysis. History. The basic concept of degrees of freedom was recognized as early as 1821 in the work of German astronomer and mathematician Carl Friedrich Gauss. He defined the notations as follows. In equation, the typical symbol for degrees of freedom is called as nu, lowercase Greek letter nu. In text and tables, the abbreviation is given as d.f. It is commonly used. R. Fisher used n to symbolize degrees of freedom, but modern usage typically reserve n for sample size. The two-sample t-statistic calculation depends on the given degrees of freedom, that is n1 plus n2 minus 2. If the value of two-sample t-test for independent samples exceeds critical t at alpha level, then you can reject the null hypothesis H0, that is, there is no difference between the two data set. Degrees of freedom formula. Generally, the formula to determine the degrees of freedom is given by n minus 1. That is where degrees of freedom is defined as df and n is the sample size. Example. Imagine a task of selecting 10 baseball players whose batting average must average to 250. The total number of players that will make up our data set is a sample size n equal to 10. In this example, n minus 1 equal to 10 minus 1, that is 9 have degrees of freedom. Baseball players can be randomly picked with the 10th baseball player having a specific batting average to adhere to the 250 batting average constraints. Hypothesis test use these distribution to calculate p-values, so the degrees of freedom directly linked to the p-values through these distributions. Example. The t-distribution is a function of degrees of freedom for the two-sample dependent case concerned. When n1 equal to 7, n2 equal to 7, the formula is n1 plus n2 minus 2. So, we have 7 plus 7 minus 2, that is equal to 12. Students, let us summarize what we have learned in this video. Psychological research is often involved in multiple dependent studies. The t-statistics is studied for two-sample dependent test using degrees of freedom. Two-sample t-test is a measure of the dependent variable and its associated variable. The various properties and notations are explained in this video, and also it is used in the dependent sample t-test or given with suitable illustration. The degrees of freedom of a t-distribution can be a function to determine the test statistics. Students, let us meet in the next lesson. Thank you.